Hi guys, welcome to Mathematics. So don't forget to like and subscribe if this video helped you. So our topic for this day is conic section. So conic section. So when we say conic section, we can imagine it as a cone. Okay, so like this one. So we have usually in conic section we have double nape circular cone like this one, double nape circular cone. So if we are going to cut this cone horizontally, if we will cut that horizontally, okay, so assuming that that is horizontal, so the cross section that will be produced is called circle. Okay. And if we're going to cut a double nape circular cone vertically, okay, so vertically like that, the cross section that will be formed will be, so it would be like this one. So it will be a parabola. Okay, a parabola. And then when we are going to cut it from the circumference and to its opposite side, the cross section that will be developed, or the conics that will be developed, is what we call an ellipse. And if we are going to cut it slant, okay, so it will produce a conic section called parabola. Okay, so those four are the basic conics section. So we have this what we call degenerate cases. Degenerate cases are special cases of conics. So there are also times that when we cut this double nape circular cone horizontally across its apex, so the conic section that will be developed is a point. Okay. So that could have been a circle, but it is a point. There are also cases where degenerate cases, let's say when we cut it slantly across this one, so it will form a line. So if there are two cuttings parallel to each other, the degenerate cases that will be formed are a pair of line. Okay, so those are some of the degenerate cases. Next, you need to remember these following formulas: distance between 2 points and our midpoint formula. Okay, so just always remember that because it is very needed in analytic geometry in conic section. So first we are going to tackle circles. Okay, so since it is the most familiar conics of all, so we have two circles here. All right, so we have this circle wherein its center is at origin, and a circle at center HK. When we say HK, the center is not at the origin. So let's find out what are the standard equations for these two. So first, let's start with the center at origin. Okay, so since we have the center at origin and we have this point xy, if we are going to find the distance between these 2 points, this will be called radius. Okay, so from our formula before, we have that as distance, so our distance would be radius. So we will write radius is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so our x sub 2, let's say it's just anywhere behind those two, so we can have that as x. So we have x minus 0 squared plus y minus 0 squared. Okay, so simplifying, this will become x squared plus y squared. Of course, if we are going to square both sides to remove this radicand, so it will produce r squared equals x squared plus y squared. And this is our So this is our standard equation of circle, center at origin. Okay? So next is our circle, center at HK. So center at HK, not at origin. So we have 2 points. We have the HK and the XY. So assuming that this will be our point 2 and this will be our point 1. So we will have our x sub 2. We can have that as x minus h squared plus y minus k squared. So r, squaring both sides to remove the radicand sign. So it would be r squared equals x minus h squared plus y minus k squared. So this is our standard equation of circle, center at HK. Alright? So our h and k is found there, and that is our center.